Hello everybody and welcome to Lesson 9, Trapezoids and Parallelograms. In this lesson you will be able to identify parallel sides and quadrilaterals and distinguish between parallelograms and trapezoids using the length of parallel sides. Let's get started. So we're going to just review on drawing parallel lines. So step 1, draw a line. I suggest on your graph paper you make it either horizontal, that is across, or vertical, straight up and down. Please use a ruler so that your line is nice and straight. Step 2, draw a second line that is perpendicular to the first one to make a right angle. So these two lines are now perpendicular to one another. So that little square shows that they make a right angle. So whenever you have one line that is vertical, one line that is horizontal, they will always be perpendicular to each other. And step 3, draw a line that is perpendicular to the first to make another right angle. So there's another perpendicular line to the first. So there we go. And now I have two parallel lines. So this line and this line are parallel. These are two horizontal lines. Remember, parallel is like railroad tracks. They're always the same distance apart. So if we measure at this end, they are 3 units apart. And if we measure at the other end, they are also 3 units apart. Quadrilaterals can be classified by how many pairs of parallel sides they have. What are the possible numbers of pairs of parallel sides in a quadrilateral? So remember, quadrilaterals are 4-sided polygons. So any 4-sided polygon is a quadrilateral. So what are the possible numbers of parallel sides? Well, they can have 0 parallel sides. They can have one set of parallel sides, one pair, or they can have 2 pairs of parallel sides. A pair is 2 lines, right? So a trapezoid has exactly 1 pair of parallel sides. So it doesn't matter what it looks like. If it's a quadrilateral with exactly 1 pair of parallel sides, it's called a trapezoid. Parallelograms, on the other hand, have 2 pairs of parallel sides. So here are some examples of parallelograms. A square is a parallelogram because it has 2 pairs of parallel sides. A rectangle is a parallelogram as well. So let's look at the term adjacent. So adjacent sides are ones that share a vertex. So let's list all the adjacent sides. Side 1 and 2 are adjacent because they share this vertex. Side 2 and 3 are adjacent because they share a vertex. Sides 3 and 4 share a vertex. Sides 1 and 4 share a vertex. So these are all the adjacent sides on this parallelogram. And opposite sides are ones that do not share a vertex. So opposite sides here would be 2 and 4. Okay, so 2 and 4, they don't share a vertex. They don't have a common corner. And sides 1 and 3 are also opposite sides. So which side is adjacent? Which side is opposite? So both of these shapes would have, both of these quadrilaterals have, they're numbered in the same direction basically. So 1 and 2 are adjacent on both. 3 and 4 are adjacent. And 4 and 1 are adjacent, and 2 and 3 are adjacent. Okay. Opposite sides would be 2 and 4 and 1 and 3. Okay, so just to go over an example, so 1 and 2 here, for example, share a vertex, so they are adjacent. 1 and 2 on this one also share a vertex, so they are adjacent. Okay. 3 and 1, for example, are opposites here and here. They don't have a common vertex. And same thing here. They are also opposites. So let's classify quadrilaterals by the number of parallel sides. So you can pause the video and you can try to write down how many parallel sides for each one. So I've indicated which sides are parallel on each one of these shapes. So now that we've done that, it's pretty easy to just record the numbers. So number 1 is a rectangle, has 2 pairs of parallel sides, so we can also call it a parallelogram. Number 2 only has 1, so that would be a trapezoid. So I'll just put P for parallelogram, T for trapezoid. Number 3, I made a little mistake here, but has 2 pairs, so it's a parallelogram. Number 4 would be a trapezoid because it has 1 pair. Number 5 is a trapezoid with 1 pair. Number 6 has 2, it's a parallelogram. 7 has 2. 8 has 1. 9 has 2. 10 has 0, so it's neither a parallelogram nor a trapezoid. We could just simply call it a parallelogram or quadrilateral. 11 has 1. And 12 has 2. If you're ever not sure, 12 has 2. If you're ever not sure, what you can do is you can extend the lines. So for 11, for example, if you're not sure if those are parallel or not, you can use your ruler to draw nice straight lines. And once you extend them, then it's usually pretty clear if they're parallel. So if I measure, they are, on my screen here, they're about 1.9 millimeters apart here at the bottom. And at the top, they are still 1.9 millimeters, nope, sorry, 1.4 millimeters apart. Yeah, they do look like they come together. So number 11, for example, good thing I double checked because those are not parallel. So number 11 would have 0 and therefore would be neither a trapezoid or a parallelogram. Number 12 I might want to, or number 8 I should say, I might want to double check as well. So when I extend them, they're about 1.4 millimeters apart and 1.4. So yes, they are parallel. So is this a parallelogram or a trapezoid? Well, it does look like these two are parallel to one another, but because the lengths of these two sides are slightly different, that would actually make these not parallel. Now I don't have enough page space to extend the lines to show that, but if I could make these two long enough, I would see that they would eventually grow apart or come together. So to be a parallelogram, both pairs of opposite sides would have to be parallel and the same length. And grid paper makes it very easy to distinguish between parallelograms and trapezoids. So I could see that the bottom here, let me use a marker. These two are 2 units apart. I see that this one is 4 units long, this side, and this side is 4 units long. And so that would make this have 2 pairs of parallel sides. Okay. Now here, I could see that we have 4 units in length at the top, but the bottom is 4.5, 4.5 units long. And so these two sides are parallel, but these two sides are not. That's going to be it for this lesson. You can go ahead and work on page 145 to 147 in your Jump Math book. Please ask your teacher if you need any help.